Hey everyone, welcome back to my channel. I'm making an additional quick video tutorial to help you prepare for the exam coming up, and this is going to be specifically on how we use factoring to solve word problems that are involving area. I'm going to go over a few examples, give you an opportunity to practice a few examples, but the whole point of this video is that you start to recognize the patterns of the same process that we use every single time we solve these problems, so that way you can solve them on your own. Alright, so here's the first problem. The area of a rectangle is 50 square centimeters. The height is 5 centimeters longer than the base. What are the measurements of the height and base? So in this problem, we are talking about the area of a rectangle. So what we're going to be using is the formula to find the area of a rectangle, which we always start by writing that formula. To find the area of a rectangle, it is base times height. Then I'm going to go through each one of these variables individually, filling in the information that I know from this problem. So first I'm going to start with the area. Do I know the area from this problem? Yes, I do. It tells me that the area is 50 square centimeters. So instead of A, I can put 50 equals, then B, do I know the base of this rectangle? And no, it tells me nothing about the base, so I'll leave it as a B, times, and then height, do I know the height? And I do not know the specific height, but I do know that the height is 5 centimeters longer than the base. So I know that whatever the base is, it's going to be 5 more than that to get the height. So instead of H here, I can change it to B plus 5. So instead of times height, it will be times B plus 5, since this is what the height equals. Then I go through and I simplify, combining what I can. So the first thing I'm going to combine is this multiplication. The B is times the parentheses, so I need to use the distributive property to multiply it by everything inside the parentheses. So I'd have B squared plus 5B. Then eventually I'm going to want to factor this, but in order to factor, all of the terms here need to be on the same side of the equal sign. So I need to cancel this 50 and bring it over to the other side. So I'm going to do minus 50 on both sides of the equal sign. I'd be left with 0 on this side, equals B squared plus 5B minus 50. Now that everything is all together, I'm going to factor it, which we can use our factor flow chart here to help us solve. So the first step, we have a trinomial, 3 terms. So the first question is, do we have a common factor in all 3 terms? And no, we do not. So we would follow the no path. The next question is the number next to the variable squared a 1 or invisible 1? And that would be yes, we have an invisible 1 here. So then I follow the yes path. So I'm going to factor by looking for 2 numbers that multiply to C, in this case negative 50, and add to B, in this case positive 5. So 2 numbers that multiply to negative 50 and add to 5. I'm going to check some numbers here. 1 times 50, that doesn't add to 5. 2 times 25, doesn't add to 5. 3, nothing. 4, nothing. 5 times 10, yeah, this could add to 5. I know that I want it to equal negative 50 when I multiply, so either the 5 or the 10 will have to be negative. If I want them to add to equal a positive 5, then the 5 should be negative, since negative 5 plus 10 would equal positive 5. So then I have my 2 numbers, negative 5 and 10, so I will write them in the format B plus or minus the first one times B plus or minus the second one. So essentially filling in the blanks here. So the first one is a negative 5, the second number is a positive 10. Okay, so now that I have it factored, I'm going to solve this. So I have this parentheses times this parentheses equals 0. So I know that when I'm multiplying, if the answer is 0, that means that one of these would have to be 0, since anything times 0 equals 0. So I have 2 situations to solve. Either this first parentheses could equal 0, or the second parentheses could equal 0. And then I solve each one. B equals 5. and b equals negative 10. So at this point, I have two options for what the base could be. The base could either be positive 5 or negative 10. So what I need to do now is think about what actually makes sense for this problem. If I'm taking out a ruler and I'm measuring the length of the base of a rectangle, does it make sense to have negative 10 centimeters? When you're measuring, do you ever get negative numbers? No, you don't. So this negative answer, it doesn't make sense. So we're going to ignore that one and use this positive answer instead. So we know that the base is going to be 5 centimeters. Then we can use this to help us find the height. So we know that the height is 5 centimeters longer than the base. So if the base is 5, the height is going to be 5 centimeters more than that. So 5 more than 5 is 10 centimeters. So this would be the final answer. All right, here's the next problem. I'm going to walk you through this one again. So the area of a rectangle is 60 square inches. The height is 7 inches shorter than the base. What are the lengths of the height and the base? So first step, we're talking about the area of a rectangle. So I'm going to first write the formula to find the area of a rectangle, base times height. Now we're going to go through each variable, filling in the information we know. So first, A, do we know the area in this problem? Yes, it tells us that the area is 60 square inches. So instead of A, I'll put 60. Base, do we know the base? No. Times height, do we know the height? No, but we know that the height is 7 inches shorter than the base. So however much the base is, it's going to be, in this case, 7 less because it's shorter, so it's going to be smaller than the base. So the height is equal to b minus 7. So instead of h here, I'm going to put b minus 7. Then we simplify using the distributive property. So b squared minus 7b. I need to get everything on the same side, so I'll cancel the 60 by subtracting 60. Now that everything is on the same side, I'm going to factor it. So I have 3 terms. So in that flowchart, the first question, is there a common factor in all 3? No. Is the number next to the b squared a 1? Yes. So to factor this, I'm going to look to see what multiplies to 60 and adds to negative 7, or multiplies to negative 60. So some options, 1 times 60, nope, that couldn't add to negative 7. 2 times 30, no, that doesn't add to negative 7. 3 times 20, no. 4 times 15, no. 5 times 12, yes. 5 and 12, if one is positive and the other is negative, that could add to negative 7. And so that's good because when we're multiplying, we want to get negative 60, so 1 should be negative anyway. So if we want to add to get negative 7, we would want the 12 to be negative, so that way we'll add to get negative 7. So I will fill in the formula with my 2 numbers. So my 2 numbers are a positive 5 and a negative 12. Then now that it's factored, we are going to solve the equation to see when it equals 0. So either this first parentheses could equal 0, or the second parentheses could equal 0. So I solve each one. B could equal negative 5, or B could equal 12. So I have 2 options for what the base could be. I need to see which one makes more sense. In this case, when we're talking about, again, measuring the lengths of a shape, negative numbers don't make sense. So this negative 5 doesn't make sense, meaning that the base is going to be 12 inches. And then the height, you can look back in the problem and see that the height is 7 inches shorter than the base. So if the base is 12 inches, the height will be 7 less than that, so 5 inches. Which makes sense because if the area we're trying to get is 60, 12 times 5 is 60, so we know we have the right answer. So now I've put on the screen 3 problems for you to try. It's the same format. You'll use the exact same process that I used, just fill in the procedure with different numbers now. So take a minute, pause the video, try these problems out, and when you have your answers, you can play the video again and I'll walk through the steps of how to solve these if you weren't sure, or to also check your answers. So pause the video now. Okay, so here's the work that you should have for the first problem. I do want to remind you that the whole point of this problem is for me to see that you can model a situation with an equation and you can solve that equation with factoring. Meaning that if you just read the problem and you use logic and problem solving to just figure it out mentally what the two answers were, that's not what I'm looking for here. The whole point of what I'm looking for is the equation and solving it. So you would not get credit if you did not have all of this work to go with your answers. So the base is 7 meters, the height is 8 meters, and the process that you need to use to solve this is we find the formula of a rectangle area, we fill in the numbers, so the area is 56, the base we don't know, the height we know is 1 more than the base, so b plus 1, use the distributive property, bring everything over to the one side. I factor by looking to see what multiplies to negative 56, adds to positive 1. Here are all the numbers I checked until finally I found a pair, and then 7 needs to be negative and the 8 positive to multiply to negative 56 and add to positive 1. So I filled in the parentheses with those two numbers, made each parentheses equal to 0 and solved. I got the base equals 7 and the base equals negative 8. This negative answer does not make sense in the context of the problem, so the base is 7. And if the height is 1 more, that would mean the height is 8 meters. So here's the work that you should have for the second problem. So again, you need this entire process to, in the end, get the answer that the base is 8 centimeters and the height is 3 centimeters. If you weren't quite sure of the work, I'll quick walk through how I did this now. So we're finding the area of a rectangle. So again, the formula is area equals base times height. I fill in with what I know. The area is 24. The base I don't know. The height I know is 5 less than the base, so that would be b minus 5. This shows 5 less than the base. Then I simplify using the distributive property and then bring the 24 over to the other side by canceling it here. And then I factor by looking to see what multiplies to negative 24 and adds to negative 5. I discovered the two numbers are positive 3 and negative 8. They multiply to negative 24 and add to negative 5. Filled them into this format, solved when each parentheses equaled 0. I got b equals negative 3 and b equals positive 8. In this case, again, negative numbers don't make sense when we're measuring in centimeters, so I disregarded this negative 3, meaning that the base would be 8 centimeters. If the height is 5 centimeters less, 5 less than 8 would be 3, so the height would be 3 centimeters. All right, so here's the very last one. The answers that you should have gotten, the base is 7 inches, the height is 5 inches, and here's the process that needs to go with it. So again, you need this process because that's what I'm checking for, that you can model a situation with an equation and then use that equation to solve the problem. So if you weren't sure of your work, let me quick walk through my work here. So the area of a rectangle, the formula is area equals base times height. Fill in with the information we know. The area is 35, base we don't know. Height is 2 inches less than the base, so it's whatever the base is, we're going to take 2 away from that. So b minus 2, I can change the height to be b minus 2, since that's what it equals. Use the distributive property to multiply this b times the parentheses. Then I bring the 35 to the other side by canceling it on this side, so it's all together on the right side of the equal sign. So now that it equals 0 and everything is together over here, I'm going to see what multiplies to negative 35 and adds to negative 2. The two numbers I discovered are positive 5 and negative 7, so I filled them into the format, solved when each parentheses equals 0. I got b equals negative 5 and b equals positive 7. So in this case, positive numbers are the only ones that make sense, so I'm going to disregard the negative 5, meaning that base is 7. And the height is 2 inches less than the base, so if the base is 7, the height would be 5. 5 is 2 less than 7. So this is the format that we are going to use every single time that we solve these area problems of a rectangle. So as long as you know this process, then you'll be totally fine. It's just filling in with different numbers. So I highly, highly encourage you, if you're still confused, to let me know so I can help you out and give you more problems to practice, so that way you feel totally confident on how to do this on the exam.